Next, we're going to speak about securing layer 2. We're going to see some of the attacks that we have previously identified in the previous days as common attacks. We're going to speak about a couple of those in more detail and then see what are the mitigation tools that we have available. And then we're going to also see some of them lively on the CLI. Some of them which are more time consuming, for example, we're going to speak about dynamic ARP inspection and DHCP snooping. Those have been already heavily, let's say, showed up in the CCNA security bootcamp. You can go ahead and reference those topics in there, for example, which have been like pretty much, let's say, heavily tested, a bit even above the CCNA level, to call it that way. Securing layer 2. If you remember, we were speaking about reconnaissance attacks. So when the attacker was performing some kind of identification of your network. So in this case, network device reconnaissance, it means that the attacker has to be directly physically connected to one of the victim's interfaces, which the victim is the network device. So if the attacker somehow manages to be physically connected to a network device, like to a switch or to a router directly, then if the network device is going to be running CDP or LLDP, which we know what those protocols means, Cisco Discovery Protocol, and LLDP stands for Link Layer Discovery Protocol, then through both of those protocols, the attacker can identify the connected device and get information about those devices. For example, in my network, if you look and I'm running CDP in here, if you say show CDP neighbors or any of the routers, show CDP neighbors, and then let's look. So I'm running CDP on all ports, and because I also have connected devices that run CDP, which are the switches, if you say show CDP neighbors detail, then of course you're going to be able to identify a lot of information about those neighbors. With the brief output of show CDP neighbors, you can only identify like what are the capabilities of the neighbors, where SI stands for switch and IGMP, and then what is the platform, which is a 3750 switch, and of course what is the port ID, the remote port ID I'm being connected to. This is the local interface that a router uses to connect to the switch. So this means that this is my interface X00, and on this interface I'm connected to switch 1's port of FA102. The output is not clear now because ideally this should have been not port ID but remote interface. That would have been much more clear. Remote interface. Because as this output says local interface, I don't know why they have not added in there remote interface, but they should have just stated port ID. But if you say show CDP neighbors detailed, you find much more information than the local and remote ports and the capabilities and the host name. You're gonna find in there, like for example, the iOS version, which that's one of the most important ones, because if you know the versions of the connected device, you may go and identify any kind of known vulnerabilities that you can use to then launch any kind of attacks to those devices. You also identify, because it's a switch, the VTP domain name, and if the VTP lacks a password, then there we go, you connect yourself with the layer 2 device, you put yourself in the same VTP domain. You have also the native VLAN, so you're not going to run into any kind of STP issues. And if the VTP domain doesn't have any kind of password, any kind of security configured, then you can go ahead and inject fake VLAN numbers and override the VLAN database. So that's going to be, for example, one kind of possible attack. But of course, it can be a lot of those. So except VTP information, the most important information is from the CDP level is going to be the iOS version running on a remote device, which is going to allow the attacker to gain knowledge about possible vulnerabilities which affect that specific iOS version, and then launch any kind of attacks. So clearly, in order to mitigate against such attacks, the only thing you have to do is to either globally disable LLDP and CDP, or only disable those on untrusted interfaces. If you disable CDP and LLDP per interface, you just say no CDP enabled and no LLDP transmit. So that's going to be the CDP command disables CDP completely both ways. The LLDP command disables only transmission of LLDP packets, but not receipt of LLDP packets. You can also optionally say no LLDP receive, which is going to be like it's going to stop sending and receiving LLDP packets from that interface. But they're mostly interesting not to send LLDP packets to your neighbor. You can receive, why not? Of course, if you want, you would want to also drop the receipt of LLDP packets if you want to stop any kind of LLDP attack towards the control plane of the router, for example. Otherwise, if you don't want to do it per interface because maybe all of your interfaces are untrusted, are connected to devices which don't belong to you, then you globally say no CDP run or no LLDP run. For example, and let's define what's an untrusted interface. Now, a trusted interface from my point of view is a link between network devices which belong to you as an organization. But then, for example, links towards the users, those are not trusted links. So on those links, you're going to leave CDP enabled, for example, or LDP enabled only if you need those. Like in the case of you want to advertise the voice VLAN towards the IP phone, which is being done via CDP. Because otherwise the ports where your users are connecting is not necessarily a trusted port, because any visitor can come in and plug to that port and send and receive CDP information and gain minimum knowledge about your devices, which means gain knowledge about what is the iOS version of the connected switch, and again can compromise it by attacking specific vulnerabilities. So like in my case in here, if you go and initially show CDP neighbors, I'm sending CDP packets by default each 60 seconds, and I'm going to time out those entries in 180 seconds in case I don't receive an update. So it means that if I go now on any of my gig interfaces, show CDP, let's say show CDP interfaces, I'm running CDP on all of my links. There we go. On gig 00, I'm running CDP each 60 seconds. And hold time is 180, likewise on gig 01. So if both of those would be untrusted interfaces, you can go ahead and say interface gig 00 and say no CDP enable. Interface gig 01, no CDP enable. So now if you say show CDP interfaces, then you no longer see those 2 gig interfaces because I'm no longer running CDP over those interfaces. But by default, CDP is globally enabled, which means I'm still running CDP over the other interfaces where I have not disabled CDP. Luckily, in most codes, LLDP is being disabled. If you say show LLDP, it is not enabled. The way you enable it is LLDP run, or disable it is, of course, no LLDP, show LLDP. There we go. It is active, show LLDP. So LLDP is the standard version of CDP, where CDP is Cisco proprietary. So likewise, once I have enabled LLDP globally, I'm going to start sending and receiving LLDP packets on all of my interfaces. The same behavior as for CDP. So what I can do is, likewise, I can go on the interface level, interface range gigabit 00 and gigabit 01, and say no LLDP transmit and option no LLDP receive. I don't want to be able to send or receive LLDP packets on those links. So show LLDP interfaces now. There you go. On gig 00, both sending and receiving is disabled. Likewise on gig 01. But on the other links, it's still enabled because LLDP was globally enabled.